they might just be all webinared out. So today, as I mentioned, I will kind of look into doing the defensive design aspects. So this is kind of looking at, obviously, carrying on with various programming techniques. So when it comes to defensive design with the OCR side of things, these are the various parts that they need to look at. We've got in here looking at the anticipating some misuse, looking at authentication. Planning for contingencies is part of the 276 spec, but they've taken it out for the 277, which is why I've kind of put that in brackets. Input validation, and input validation has got sanitization as well, kind of looked in with that as part of the 276 spec, and it's been again removed from the 277 spec in there. A lot of the kind of sanitization and validation are kind of fairly similar, so it's kind of things that we look at the same time. And then there's maintainability in there as well, so it kind of links back to one of the previous sessions that I've done where we've kind of looked at using maintainable code and that sort of thing. The planning for contingencies side of things is looking at kind of maybe data duplication and that sort of thing, to make sure that if data is lost, then it can be got back and that kind of thing. When we're talking about sanitization, we're looking at the kind of removal of extra characters that aren't needed. We're also looking at kind of making sure the data is in the correct format and that sort of thing as well. The others I'll talk about a little bit more as we go through the next slide. The maintainability side of things, see, this kind of helps with the defensive design aspect because it allows people to easily change the code when it needs to be changed and hopefully just stop with any errors getting through as well. But I said I kind of teach this bit as a separate part earlier on. I can't remember which session number it is now, but it is one of the previous ones that I've covered earlier on, that you can find and catch up on YouTube if you haven't caught up on it or seen it initially. When it comes to kind of writing algorithms, like I've said before, it is useful to think about getting them to write it in a nice structured way that's easy for the examiners to mark. Things like writing functions in capital letters and any other keywords in capital letters just helps it to stand out more than anything, so that it's really clear what they're trying to do. Sometimes if they don't do that, it can look a lot like they've just put in some random strings and things like that. So it's just kind of more exam technique rather than what they need to do, but it does help as you go through to pick out those keywords. As I've mentioned before, and I talk about a lot if you've been on the previous ones, we're looking at using prim, and I use that with all of the teaching of programming now, right up to kind of introducing things at A level. It's really useful to do. As they go through and start to understand things a little bit more, you can kind of remove the prediction stages of programs in the running and giving them programs to begin with, and then it can just be about them making tasks. But I think especially in the beginning, it's really useful to be able to have that code to have a look through and start to understand what's going on first. And then this is just an example layout of how we do it. And you can access this on CAS if you would like to download the full scheme, although it does need updating a little bit, and I'll try and do that within the next week or so, hopefully. So just a little bit more on defensive design and kind of what we're going to look at in today's session. So anticipating misuse. So this is kind of the idea that some people will either kind of deliberately or accidentally kind of use the program in a way that it wasn't intended. So it could be that they've accidentally typed in a value that can't be accepted, or shouldn't be used, or it might be that they're trying to break the system. But see, one of the kind of key bits is trying to thinking about all of the different combinations, and all of the different things that a user might do, and try and put in some code that will then prevent that from causing any issues. And generally that's just from kind of error handling, which we'll talk about a little bit more going forward. Authentication is one of the other aspects, which is where we can get the program to only allow certain users through. So they need to have logins of some description. This may be full kind of protected logins where you think about kind of biometrics and top security things, or it could be as simple as just putting in a username to say this is who it is. And obviously, depending on the system, will depend on what type of authentication needs to go through. With the GCSE, just a simple username password check is fine. And I'll show a couple of different ways of doing that kind of later on today. Then you've got the input validation side of things, so checking that the input is not accurate, because it can't necessarily say that it's an accurate number or an accurate answer, but what it can do is say, is it something that's realistic? So some of the things that I tend to talk to my students about when I'm introducing validation for the first time is things like if we're typing in someone's age or asking for their age, something that would be kind of realistic would be maybe any number between 0 and 100. But I could type in 60 as my age and that wouldn't be correct. So it can't necessarily check that it is correct, but it kind of helps to make sure that it is more realistic and it's something that is an acceptable value. And like I said earlier on, the maintainability side of things just helps to improve it. So if you do find any errors, you can go through and you can kind of fix them and make sure that the final program doesn't have those issues in there. And like I said, the maintainability side of things we're not going to focus on today. It's mainly the other three areas that the next few programs will go through. Feel free as we go through, if there's anything that you've got any questions about, to put it in the chat or just speak. I don't mind being interrupted. There's only a few of us, so if you have got something, then please just let me know. So as with kind of most of the other courses I've done so far, the presentation, so you can find this presentation using the link at the bottom of the screen there. Hopefully you can see that all right. Let me know if you can't and I'll put it in the chat. So we've got a first program here. So this kind of links to work I would have done on string manipulation with the students earlier on. And this is kind of more input sanitization that we will look through as we go through. So with the program, hopefully the students will have picked up what the different parts will do and work out kind of what it's doing and be able to link that into the input validation sanitization side of things. So obviously the first bit is to kind of get them to write down what they think might happen. Just remembering that this is a stage where it really doesn't matter if they get it right or wrong. You are just really looking to see, can they start to read through the code and then kind of build on from there. And feel free if you want to say what you think it might do, whether that's in the chat or just by speaking. Then they can start to run the code, and we'll see at that point I get them to type it in because I think it just is useful for them to be typing the code in and getting used to the syntax. Some methods just download the code and you then just run it, and I think it's just down to what you think is suitable at the time. Some of the larger programs, it might, if they get quite large, it might be worth just having a copy that they can download and just run. But with this one, it's just then about thinking about the kinds of things that you want them to look at. So with this one, I will initially pick out an error that I've put in here deliberately. So there's an error in here that means that it's not going to necessarily work as intended. I don't know if anyone has spotted what that might be. So in here, the problem in here is that we're using the dot lower function. Dot lower will put everything from the input into lowercase. So whatever they type in, regardless of whether it's typed in, dot will be turned into lowercase. Which means that when we try and compare it to the string London that's got a capital L in it, it will then obviously not be a match when they do in fact get the answer right. We've also got in here a bit to think about why this dot lower function can help to avoid user errors. I don't know if anyone's got any ideas of how that can help with kind of stopping the program working properly. Yeah, so it eliminates different string variations. So it means that it doesn't matter how they type in London, whether they put in it all in capitals, all in lowercase, with a capital L at the beginning, whatever happens, it will still treat London as London, which then just helps to make sure that it gets right, gets marked as right when it should be right. I then get them to think about using the upper instead. So if we were to change it to use upper instead, what would we need to change? So we'd firstly need to change the dot lower to be dot upper. We would then need to change something else as well. Yep, so we need to change the string London to make sure that is all in uppercase. Yep, well done. And then, as always, I'll throw in one of these about the computation of constructs. Again, I think it's really important that the students are picking out the constructs and are able to identify them as they go through. So the main one, if this was an exam question that they would be looking for, would be the selection, but obviously this is also a sequence as well. We've got a set of instructions in order as well. And then obviously we move on to the modify. So hopefully, obviously we've talked about the error that was on line 3. So the modify at this point is just make sure they've got a version of the code that runs without that error. So it's all been fixed. So if we take it back as the dot lower, what change would we need to do to make sure that it does all work? So how we can change line 3 so it does work, sorry. So what would we need to change on this line so the program does work as we expect it to? Yeah, so we need a lowercase l at the beginning here, and then that means that it will work as we expect it to. The make one is a very similar task. So now it's just going to look at checking against a name. Doesn't really matter what name they choose. So they might choose their own name, they might make up a name, and it will be virtually the same program that we've got before here, where we just ask for their name. They can use upper or lower as long as they use it correctly. I'm not too fussed. As we know, there's always more than one solution to a problem. So being able to use either of them is fine. So you could have where it's name.lower, if we decide to use the name variable, for example, equals the name that we're looking for, and then obviously we can then print correct from there if we need to. Another way that we can look at defensive design is by looking at kind of error handling and error exceptions. I don't know if this is something that anyone has used before. This one tends to be something that is a little bit more complex to get your head around. It's not something that I would probably expect low ability students to be using and probably not understanding, especially not at the beginning. They'll take a little while to get to this stage, and so this task is one of the last one of the kind of series of defensive design, but it is a really useful tool, especially for those high ability ones that are going to go on to kind of A-level work and higher. They can use these try and accept functions. I don't know how many of you use those before, whether you understand what they do. But has anyone got any ideas what this program might do? So the idea of this program and the try and accept is that we give it something to try to begin with. So here we're using the input function to get an input. It will then try and turn that into an integer. So this is the bit that we're kind of checking. I'm just going to get my pen again. So we're checking to see whether this can work. So as well, you're just saying, we are looking to see whether it's going to be a number that is input in this case. So if the number entered, or if the input entered is, let's say 2, for example, the int function can convert that string input. Oh, that's a really bad set of apostrophes or speech marks. I apologize for that. So if the string 2 is typed in, then that can be converted or casted into an integer quite easily, and that won't cause any issues. If, on the other hand, the user types in, let's say, the word 2, sorry, I'm using a mouse, which is why it's so bad. Instead, that word 2 can't be converted into an integer. So what would happen in Python is an error would be thrown, and that's where the kind of the try and accept comes in. So what happens is at this point, the accept part of the try and accept is run. It basically says we've got an error. Try doing something else instead, or do this instead. And so in this case, I'm just going to print that this is an invalid input. If they had typed in the number 2, then we've got this else part to run, and this is just going to return the number. Okay? And that's fine to go through. And so it is I've just been asked if I've got an example that repeats. That's actually something that we're going to move on to, and is part of the I think it's the modify part or the make part of this activity, looks at getting it to repeat after we get it wrong. So with the investigate side of things, we're looking at, initially I just want them to think about what is this checking for, and so we've already covered that this is checking, is it a number? So is it a number that's been typed in and not a piece of text? You can, another thing that I look at is what happens if nothing is entered. So what happens if we type it in and nothing is typed in at all? So we just press enter, for example, and we should get invalid input again. Then we've got the purpose of the accept. So I talked through how that is then kind of run if there's an error. So if an error is caused by the try part, then the accept part is run. Then we've got in here a little bit of a link to the sub-programs that we've done previously, or that I will have taught previously, and just kind of recapping which type of sub-program has been used, whether it is a function or a procedure. And so at this point, does anyone know which one this would be?
Function.
Yep, function. Okay, so we're returning something, so it's a function. Procedures don't return anything. And then we've got a think about where this might be used. So why might we be using it? So get them to think about any example where they might want to find out that it's a number. So it could be like a mathematical thing, so you're going to do some maths with it. So you might want to add two numbers together and you want to make sure that they're both numbers that have been input or something on those lines. And again, I like to add in the constructs part in there. So we've got obviously sequences. You can talk about the try and accept being a bit like an if statement, so you could argue that selection is used as well, and some of your students might argue that. The next part is where sorry,
before you move on to that next section, a couple of questions.
Yep.
If a user presses enter without putting anything in, a value in there, is that null entry? What's the correct terminology? Is null?
So null entry is fine.
How null is used sometimes.
Yeah, no, a null entry is fine. Python tends to talk about it being a none entry instead, or a non-type.
I've seen that, and that.
But none.
N-O-N-E. But what would the OCR see that as? If
OCR would talk about it being null because none is Python specific, and it's basically the same thing.
Can I ask you a quick Teams question? I haven't got chat. It says chat in channel meetings is only available to team members.
Okay.
Because I wasn't sure if people were putting text.
Wahid is putting some stuff in the text.
I don't need it. It doesn't matter. It's just because you're recording, so it doesn't interrupt the recording.
Yeah. No, I mean, feel free to ask away as normal if there's something. I'm more than happy to have questions as we go through, because I think it just helps to keep it a little bit more interactive. And when there is a question, it's relevant to what we've got on the screen at the time. So feel free if there's anything.
The last question, the try and accept for Python, is that a Python construct? Or is that something you see in other languages as well?
So you do see try and accept in other languages. They might not necessarily be called try and accept. Sometimes it's try and catch. There are other terms as well, depending on the language. But most languages do have this kind of error handling in there.
Thank you.
Okay. So the... Oh, no, that's not. I've forgotten to copy the right bits over. So the modify part in here would be the bit where I'm trying to get them to get it to repeat if there's a mistake. So when it's invalid, it can then just repeat it. And what I would be looking to do is, because I've got them using this function, is that they just call check score again. So what we can do is just inside here, where the once we've got the print invalid input, we can then just have check score typed in again. I'm not going to bother typing it or trying to write it out with my mouse because that's going to not end very well. But we just type in this whole section, so there's just the check score, open bracket, close bracket, would go on line 7, and that would then be repeated.
Right. Sorry.
No, sorry, that's fine.
You're going to call the function within the function.
Yeah, so you call the function within the function. At GCSE, you don't necessarily need to talk about this, but at A level, we start to talk about that being a recursive function.
Yeah, I've just been doing that. I call the function within the function. Thank you.
Yeah, so recursion is one way of creating a loop, and it's in some ways it's quite an easy way to create a loop, but some students really find it difficult to get their head around.
Yeah.
Another way that you can do it is Wahid was saying that he uses a while loop instead of the function side of things. So you just put the try and except within a while loop, and at some point, so after the try, when it's been successful, you kind of flip your little counter or whatever it is you're using as your little flag to say that yes, it's okay, so it stops the loop. Either way is completely okay to use. You can potentially, as programs get quite large, doing it in this way can be seen as a kind of a negative way of doing it, but I find it's quite a straightforward way for students to start to learn about. So hopefully that answers most people's questions. But if there is anything else, then please let me know. So then the next part is where I start to introduce authentication to the student. So this one would be a new lesson. So I spend kind of, there's 4 activities based around the input validation side of things and the kind of the sanitization and that area that we talked about. And then the other part is kind of the authentication. So I'd have about 4 activities linked to this as well. And this is the bit that I haven't actually added to my CAS work yet. So I do need to do an update of my CAS prim work at some point, and I'll try and do that in the near future. So with this one, we're just looking at very simple authentication. So this is just looking at a username that exists and have they kind of logged on before. This is something that they can get away with in programming projects as being a form of kind of authentication, especially for the lower ability students. And so with this one, I'd be looking at thinking about the kind of linking it to what we've done beforehand. So thinking about how the username is typed in, what's important about it. So this one is thinking about, we haven't used any kind of validation or sanitization on the input. So I'm looking for the username to be typed in with a capital M and a capital S for it to be accepted. And so the students can kind of talk about that and hopefully apply what they've learned previously. The how could this be improved? This is just talking about the using the upper or the lower functions in there like we did in the first activity, and just again getting them to make those links. See, the simple authentication system is just because it's only using one username, so there's only one valid user, and that valid user doesn't have to type in a password as well. It's only looking at whether it is a has a valid username, and then just looking at again the constructs, just done in a slightly different way this time. The line number where we've used selection on here, and you'll see that's line number 5. So it's quite a very simple one. This would be the first authentication one that I do with them, just so that some of the low ability ones can start to see how it might be used. modify, obviously that's where we get them to make that change, so it can be typed in using upper or lowercase and so on. So making that change we talked about in these first two questions here. And obviously that'll then go link back all the way to what we did in this example, and hopefully they can spot those patterns, which is obviously really important to do. The make part is then just to get it so that it will do the same sort of thing, but ask the user to try again if the username is incorrect. So this is where you could introduce a loop to go back through, maybe redo it so that rather than using an if statement, you use a while loop instead. So while the username is not equal to the correct username, then keep asking them to enter it in again, or something along those lines. Does that make sense? Any questions with that at all? Excellent. And then the final part to look at today is looking at kind of a more advanced kind of authentication system. So this one has got a valid user and their valid password. And so getting them to think about what's going on with this one. And so we've got in here a slightly more complicated if statement this time. As we go through. Why is that not copied over? Hang on. Just bear with me. That hasn't got the right one. Clearly, as I copied it over earlier, it didn't do the right screenshot. So with this one, we're now starting to think about kind of why this doesn't work properly. Has anyone spotted why this login system might not work properly?
Because of the Boolean in line 7.
Excellent. Yeah. So that's what I'm looking for. Perfect. So obviously this will let them in if either the valid username is right or the password is right, and also obviously if they are both right as well. Obviously we don't want that. We only want it to be if they get the username and the password correct. And then obviously they can then look at the constructs again. So at the moment, obviously there's a lot of doing that with these sections. At this point, obviously think about what happens if the login details are not known. And so at the moment, nothing happens. It's a complete kind of blank part. And then we'll get them to think about what should happen if the user guesses incorrectly. So that could be anything from just saying, well, let them ask again. Maybe they might start to talk about the user having a certain number of guesses, so they're only allowed 3 guesses, and then they get locked out of their account. So anything along those lines is fine. And so obviously the modifier is to fix the mistake, so obviously changing or to and then the make again is to get them to do it so that a different program, but it allows them to try again if the user types in the details incorrectly. So that'll be similar to using that while loop that we talked about previously. And then I think for the exam, I would say that this is as complicated an authentication system as is needed. You don't need anything really much more complex than this. For those of the students that are kind of the high ability ones, if you're giving them projects, so year 10s, if they haven't done their projects yet, they might want to do something a little bit more complex, which means that maybe you use an array that has multiple users in and multiple passwords in, and then they have to use a loop to go through and check all of the combinations to see whether the user exists. Or even using a database like we've looked at recently, and storing users in a database and checking it. Both of those two methods I do show, and they are on the version that I will try and get uploaded onto CAS on my my prim work that I've put on CAS, if you are interested in using those. But I think for a kind of GCSE exam kind of level, they don't really need to know much more than coding up to that point, I would imagine. And I think a lot of your lower ability students would really struggle with anything more than just a variable with a username and a variable with a password in there. Don't know if anyone's got any questions at all now. Perfect. It's always good to know that everyone understands. That's really it for today. What I can do, if you're interested in hanging around for a little bit, I can show you the examples of the slightly more complicated defensive design aspects, and you can have a look through those if you are. So this is where I've got them to have an array, and we're using a 2D array, which is something that we do look at previously, which has got all of the valid users in there that they can then go through and have a loop that checks whether they are logged in or not logged in. And then I'll just zoom in a little bit on this one. This one has got a database, so it basically does the same as activity 3, but before it can do the loop, well, actually this does it a slightly different way. This uses a function in SQL to count how many rows there are, so it doesn't have to do the loop. It just looks at how many records are returned, and if the number of records returned is 1, then they're logged in, otherwise they're not logged in. But you could quite easily just do a loop instead to check through the result variable and see whether there is a match or not in there as well. But you can probably see why I wouldn't expect kind of low ability students to be able to kind of code or even necessarily understand what's going on with these two activities. Any thoughts or questions or anything? Okay then, so that kind of brings the end of this session, so session 11. I will do another session next week where we'll start to look at kind of testing and how you can kind of go through aspects of Prim with testing as well. So feel free to join me next week. We'll do the same time next Monday as well. I'll just stop the recording.
Thank you.
Not a problem.